Projectile motion learning activity. We have here the setup for the learning activity. At the initial position, y naught equals 0, t naught is 0, and since the water came out from the hole, to the right, alpha naught equals 0. For our learning activity, we are to get XF experimentally. So theoretically, we will derive XF. So to derive the theoretical horizontal distance XF traveled by the water in projectile motion from the hole to the ground, we first recall the past lesson about principle of conservation of mechanical energy, which states that the sum of an object's potential energy PE and kinetic energy KE is constant. We then incorporate projectile motion equations to this conservation of energy principle as the water travels from the hole to the floor. To start, we write the conservation of energy of the water in the can before initial opening the hole, left side of the equation, and after opening the hole, right side of the equation. So we have here our conservation of mechanical energy. Kinetic energy initial plus potential energy initial is equal to kinetic energy final plus PE final. So this is our conservation of energy. But we have kinetic energy is 1/2 mv squared, and potential energy PE equals mgh. So we write explicitly this equation 1/2 mv initial squared plus PEI mghi equals right side of the equation KE final 1/2 mv final squared plus PE final mgh final. But before the hole is opened, KEI initial is equal to 0. And after the hole is opened, PE final is 0. So let me write this down. Before the hole is opened, so initial, left side of the equation, KEI equals 0. And after, so right side of the equation, after the hole is opened, PE final equals 0. Here we are talking about the initial height of the water. So thus this becomes 0 and this becomes 0. So we have mghi equals 1/2 mvf squared. Now we divide the entire equation by m. So we are left with GH initial equals 1/2 VF squared. And so transposing what you're after here is our V final. Transposing our 2 to the left, cross multiply, 2GHI equals VF squared. And extracting the square root, we get the V final, square root of 2GHI. Now this V final, VF, is transformed to become the initial velocity V naught. Looking here. So the velocity V final here is transformed to become the V naught of our projectile motion of the water. So this is now our V naught. Thus, we will say square root of 2GHI equals V naught. Moreover, since this water is physically coming out from the hole to the right or along the horizontal, this initial velocity is therefore the initial velocity of the water along the x-axis. Okay, so this is along the x-axis. Let me write that one down. Vox is equal to square root of 2GHI. Now in projectile motion derivation, recall 3.1.d. Okay, we now go to the projectile motion equation. Recall projectile equation 3.1.d, and that's V naught x equals V naught cosine alpha naught. Since alpha naught equals 0 in our situation, so V naught x equals V naught. Okay. And replacing this to this, we have square root of 2GHI equals V naught. Let's call this one 3.13. 3.13. Let us call this 3.13. Now our objective in this learning activity is to get the distance XF experimentally. From one of the projectile equations of motion, equation 3.5, we have the expression of XF as recall projectile equation 3.5. We have there XF is equal to horizontal distance. Final horizontal distance equals V naught cosine alpha naught t. But since in our experimental setup, water comes out from the hole to the right, again, alpha naught equals 0. So this will become, and cosine alpha naught equals cosine 0 equals 1. So this will become VO. This is now 1 VOT, our XF. Cosine 0 is 1. Let's call this one 3.5 point D. So we now plug 3.13 into this 3.5 point B. 3.13 this V naught of 3.13, we plug it into 3.5 point B. Plugging 3.13 into 3.5 point B. So we have XF is equal to square root of 2GHI times time. Let us now obtain the equation for the time from 3.5 point C. Okay, to do this, we recall the projectile equation of motion 3.7. Containing the expression of T from the experiment setup. Okay, so we first recall projectile equation 3.7. We have YF is equal to V naught sine alpha naught T plus 1/2 GT squared. Now in our setup, alpha naught equals 0 and sine 0 is equal to 0. So our first term drops and we are left with the second term. 1/2 YF equals 1/2 GT squared. What we want here is the expression for the time. Divide the entire equation by 1/2 G. 1/2 divided by half. 1/2, that's 1. G over G, that's 1. So we are left with T squared equals YF over 1/2 G. Okay, let us first express the left side of the equation as numerator times the reciprocal of the denominator. 1/2 G is G over 2, so times 2 over G. So 2YF over G is the left side of our equation. So the left side is 2YF over g equals t squared. We want only t, square root the entire equation. So square root of square is 1. So on the left side, square root of 2yf over g. On the right side, you have time. And so this is now equation 3.7.c. And we plug this one into our XF. 3.7.c into this equation. This is actually 3.5.c. Plugging that into this 3.5.c equation. Thus we have XF, the 3.5.c. That's XF is equal to square root of 2GHI times T. And this is the T. Times square root of 2YF over G. Thank you for watching.